Hannah. I'm a tutor at Sky Academy, and we're looking at the topic of statistical analysis within the Year 11 standard course. We're looking at exploring and describing data, which comes under MSS1. So we're going to have a look at outliers in this video. And an outlier is just a data point that is alone or by itself away from the rest of the data. So an outlier is a score that is separated from the majority of the data. It's called outliers because they are considered outside of the data set. So for example, if the data set was represented by this dotted line here, if we had a dot that was up here, it is outside of the data range. It is away from the data set. It is considered an outlier above the rest of the data set. And say we had a point of data here, the yellow one, which is below the rest of the data set, it is considered an outlier below. So there's two types of outliers, the red one, which is above the rest of the data set, or the yellow, which is below the rest of the data set. So if we have a look here, we have two formulas. We have Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR. So the one with the minus in it is the way to calculate an outlier below the rest of the data set, and the one with the plus is the one to calculate an outlier above the rest of the data set. So if we look at this image or this diagram below, if we pretend that our data is between these ranges here, then anything outside of that range or over that cutoff point is going to be an outlier. So this one here will be an outlier above. So that would be calculated using the Q3 plus 1.5 times IQR. And this here would be an outlier below. So it would use the Q1 minus 1.5 times IQR. So when we use these two formulas, you get a value. So for example, if you do one for below and you get a value of 5, and you do one for above and you get the value of 16, anything below 5 would be considered an outlier. So 5 would be the cutoff point, and anything above 16 would be considered an outlier. So 16 would be the cutoff point. So that's what outliers are and how to calculate them. So let's have a look at an example of determining an outlier. So it says find the outlier and then find the effect on the mean. So before we do this question, we need to consider why they asked us to find the effect on the mean. Now they've asked us this because if you have large sets of data, then the outliers will have little to no effect. They might have a tiny effect, but generally they'll have no effect on the mean or the measures of central tendency. Whereas if you have a small data set, it will have a great effect on the mean and a small effect on the median. So a small data set may only have 5 values, whereas a large data set might have 500. And the reason we need to calculate the outlier to see the effect on the mean, or to see its effect on the measures of central tendency, is because, say for example, you have a test, and say it's the English HSC trial exam, and majority of the scores was a mark between 50 to 70%. So that's where majority of the scores is. So the average would be between 50 and 70%. And what if somebody got 99%? That might be considered an outlier. And because it's an outlier, it might drag the average up a little bit to say 76%. And so if you're sitting in the 55 range and you see that the average is 76, you might think to yourself that you did really poorly in that exam because the average was 76. But in actual fact, the average might only be 60, but because the outlier is considered in the data set, it brought your average up. So it makes it look like the test was easier when actually the test was a really hard test, but just one person was able to do amazing in it. So that's why outliers are important to determine the effect on the mean, because it gives a false representation of the data. So let's have a go now at finding the outlier and then determining its effect on the mean. So if you remember the outlier formulas, we have two. We have the Q1 minus 1.5 times IQR, and we have the Q3 plus 1.5 times IQR. So what we need to find is we need to find Q1, Q3, and the IQR. And to find the IQR, we need to find Q2 and Q1 and Q3. So we need to find all of these values before we can sub them into the two formulas. So let's go ahead and have a look at our data set to find these four values there. So firstly, we need to make sure our data set is in ascending order from lowest to highest. So if you do a quick skim, all of our values are getting bigger as they go along. So that's fine. So now we can find our Q2, which is halfway, the median, which is halfway. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. We have 12 numbers. So halfway is going to be at the 6.5 data point. So let's go 1, 2, 3, 4, 5, 6. So our data point is going to be at 6.5. So Q2 is going to lie there. So to figure out what Q2 actually is, because it lies halfway between 17 and 40, we can just do 40 plus 17 and then divide it by 2. And when you put that into your calculator, you should get the answer of 28.5. So now we're going to do the same for the first half, which is in yellow, and then the second half of the data, which is in green. So let's do the first half first. We want to find halfway, the median of this half, which will be Q1. And we go 1, 2, 3, 4, 5, 6. So once again, it's going to be 3.5 because half of the 6 plus 1 divided by 2 is going to be 3.5. So that's how you find where your median lies. You do the number of the scores plus 1 divided by 2. We did this in a couple of videos prior. So we need to find the 3.5 value. 1, 2, 3, so 3.5 is going to lie here, and that's going to be Q1. So now we're going to find the average of those two, which is 12 plus 5 divided by 2, and that's going to be 13.5. And now we're going to do the same for our green. So 1, 2, 3.5 is going to lie here, and halfway between 45 plus 68 divided by 2 is going to be 56.5. So now we've found Q1, Q2, and Q3, we can find the IQR, which is Q3 minus Q1. And that's going to give us 56.3 minus 13.5. Oh, that should be 5. I don't know why I wrote 3 there. 56.5. 56.5. And when you do 56.5 minus 13.5, you should get an answer of 43. So our IQR equals 43. Now we can sub these values that we just found into our first and second formula to figure out if our outlier is below the data set or above the data set. So let's do number 1 first to figure out if it is below. And so we want to do Q1, which we know to be 13.5, minus 1.5 times our IQR, which is 43. And when you put that into your calculator, you get a value of negative 51. So anything below negative 51 is considered an outlier. And if we have a look at our data set, our lowest data point is 5. And that's not below negative 51. So 5 is not an outlier. So now let's have a look at our second equation to see if it's above the data set. So we have Q3, which we know to be 56.5 plus 1.5 times 43. And that gives us the answer of 121. So anything above 121 is considered an outlier. And if we have a look, we have 122. So therefore, 122 is an outlier because it lies above our cutoff zone of 121. So pretend 121 is a cutoff zone. Anything above that is an outlier. So now we've found the outlier, we have to now determine the effect on the mean. So to do that, we are going to calculate the mean with the outlier, and then we're going to calculate the mean without the outlier, and then we're going to compare. So to calculate the mean, we're going to add up all the scores, including the outlier, and then divide by 12, which is the total number, the number of the scores. So it should be 462 divided by 12, and that should give us 38.5, which we can round up to 39. Now we're going to do the same to find the mean without the outlier. So we're going to add up the total sum of the scores without the outlier. So we ignore the 22. And then we are going to divide by 11, because then we'll have 11 scores because we got rid of 1 score. So then it should be 340 divided by 11, and that will give us 30.9 or 31. So now when we're comparing the mean with the outlier to the mean without the outlier, we can see a difference of 8. And that means that the outlier had a huge effect on bringing the mean up. And so that's why it's important to calculate the outlier and consider what it means. So the outlier had a huge effect on this small data set, had a huge effect on the data set's mean, because we have a difference of 8. So without the outlier, we'd only have a mean of 31.